Hi viewers, welcome to NCKHUB Consulting and Training. From this video, we will be starting to discuss on the Java 9 features. So, as part of our Java 9 playlist, this will be our first video in which we will be covering 3 features from Java 9. Let's get into the content. So, in this video, we will be covering the private methods inside interfaces, and the second feature we will be covering is Java collection factory methods, and the third feature for this video is Streams API improvements compared to Java 8. So let us go one by one with practical examples. The very first one is private methods inside interfaces. So in our Java 8 playlist, while we were discussing about the interfaces, we have discussed like there are new features that were implemented as part of Java 8, more particularly to the interfaces one. It is like we are allowed to write default methods as well as static methods inside an interface. And now adding more features to it from Java 9, we are allowed to write private methods as well. This will help the programmer more effectively to avoid repetitive code inside the class and can have a private methods, and these private methods can be called from any of the default or static methods. So we are allowed to write private static non-static methods to enable reusability and also avoid redundant code. Let us see this in an example. So here is an interface which was created on top of Java 9, and this particular interface, if you see, will have different kinds of methods like abstract method, default method, static method, and a private non-static method and private static method. Method 1 is a abstract method. Method 2 default method. Method 3 is a static method. Method 4 private non-static, and method 5 is private static method. So to implement this interface into a particular class, I created a class here, private method main class. So this is the class that is implementing the interface which we have here, and inside that, since we have only one abstract method as part of our interface, I am supposed to override that method inside the class, and this is the override implementation for which I have given the sysout as inside abstract class. And inside the interface methods, for every method we have here, I have provided a sysout. Now inside the main method of the class, I created an object. So this is static polymorphism, where I am creating an object to an interface using the class itself directly. And once the object is created, I am making a call to the method one, for which I have provided the implementation here, and I am calling method 2 inside the interface using the object. So this is a default method, and inside the default method I am making a call to private methods, the both private methods that are here. Okay, private static as well as non-static. And since method 3 itself is a static method, public static method, I am making a call to that method from the class using the interface name itself. Okay, now let me try to execute the program. First of all, we haven't got any exceptions or any errors while we declare the private methods. It means like from Java 9, we are allowed to declare private methods, either it can be static or non-static inside an interface. Okay, now let me try to execute this program. So if you see here, the method one I called, I got the first result as inside abstract method, and the second one I called as a method 2. So I have got a private method there. because inside this method 2 the first call was to the method 4, which is a private method, and the second call was to the method 5, private static method. And then we have the last result as default method. If you see the exam output here again, so abstract method, private static method, and then default method. Okay, and inside, and then we are making a call to the method 3, private static method. Okay, inside the static method also we are making a call to the private static method. So this is how we can create private methods along with default methods and also static methods inside an interface. So hope we are very clear on the very first feature as part of Java 9. Now let us go to the second feature. So these are nothing but the factory methods related to the collections. So these factory methods are special type of static methods that are used to create unmodified instances of the collections. So when I say unmodified instances of the collections means we are allowed to create a collection objects with fixed number of elements inside those collection objects. It means that adding a new element will not be supported. It's a new feature as part of Java 9. Before Java 9, if we have to create a collection object, this is the way we do it. Let me open the example. I have taken a list example here. Okay, so the normal way of creating a collection object is this is the way in line number 10, and the way we add elements to this list using the add method. This is similar to list, this is similar to set, and this is similar. I mean, for map, it is like we use put method to add the elements to a map, but more or less we keep adding using additional methods, and this is a kind of a repetitive code where if we have to add 50 elements to a list, we need to add like do the same logic for 50 times. Okay, so for smaller ones, for example, let us say in this example itself, we have 1, 2, 3, 4, 5 elements, 5 elements adding to the list object. So as part of Java 9, how we can do this is using the list.off method. So by using list.off method, we can give the strings as a variable arguments to this method. Okay, but the problem here is this is a fixed number of elements. You cannot add any other element to this particular list soon after it got created. If you have to add any additional element to the list, you need to add here only. You cannot add it separately. Now let me try to execute this program first. See, now we got the output. We were able to get see all the 5 elements that are there in the list inside the output. Now let me try adding a new element to the list. Okay, on line number 10, what I'm trying to do here is I'm trying to add a new element to the list. Now let me execute this. See, here we got unsupported operation exception. So whenever you are trying to use these kind of factory methods for creating list objects or any collection objects, you are not supposed to add any new element to that particular collection object. It's a fixed number of elements. So this kind of use case can be used only if you are confident that the collection object which you are going to create is a fixed number of elements. Now let me again comment this particular one and then execute the program again. Now if you see, I am getting the output now. So similarly we have a set example here. Let me take that as well. So similarly for set also we have a dot off method which is of same functionality, and this also will not allow adding additional elements. The only thing is whatever elements, fixed number of elements, we should add here only. We cannot add separately. Let me try to execute this as well. So now we are able to see this, and if we try to add additional elements, we'll come to see the same kind of exception which we have seen for list interface. Okay, unsupported operation exception. Now let us go to the map. I'm just commenting it again. Now let us go to the map. So map, we have two examples here. It will be a little interesting over there. Okay, so in case of map, the first example we'll still go with the same approach, dot off method, where we have three elements inside the map. So I tried to add a fourth element using map.put method. Let me try to execute this by uncommenting the line number 10, and I ended up with the same exception, unsupported operation exception. Now let me comment this particular line number 10, and then execute that. See, I am able to get the response. So this particular of method is used to create collection objects for finite number of or fixed number of elements. If you are unsure about the number of elements and if you are expecting some dynamic behavior, this is not advisable. Okay, now let us go to the second example of map. Okay, this is a bit interesting here because we are using off entries method. Okay, earlier examples we have discussed using dot off method, which is a factory method. Now we are using off entries. So what I am trying to do here is I have two map objects, and these two map objects I am trying to pass in as an input to the map dot off entries method. Okay, now let me try to execute it by printing it. So this is the way we get the output. So what does it mean is this particular object, this particular map element, the two objects are whatever we have, the elements inside these two maps or map entries will be copied or added to this particular map object by using the map dot off entries. So map is an interface, and off entries is a method, factory method inside this interface, and this have the ability to take the entries, map entries. Here is the method syntax if you see here. Okay, so this is the way we can pass the entries, and line number 10 and 11 are the ways we can create entries using the map. Okay, now I'll we try to execute this program and we have seen the output. Now let me try to add a new element to this particular map object. The map object which was created on line number 13. Okay, let me execute, and we again end up with the same kind of exception. So whenever we create collections using the factory methods, irrespective of what method we are using, those factory methods can be used only for creating collection objects with fixed number of elements in whatever factory method you use. You cannot add any additional element to either list, set, or map. Okay, so this is the examples that we have for the factory methods. There are lot many methods that are considered as factory methods, but I am just covering only couple of methods here as part of our examples in this video. So that's all we have for factory methods. And the next one we have is the Streams API improvements. As we discussed in our previous videos, Streams API was introduced in Java as part of Java 8. So before Java 8, we do not have anything as part of streams. And as part of and we have seen lot many operations as part of our earlier videos. Now, as part of Java 9, what are the two additional methods, or what are the additional methods that were introduced or added as an improvement to the Streams API? The two methods, what are they? Take while and drop while. Additional to these two new methods, they have provided two overloaded operations. sorry, overloaded operations to two of the methods that are off nullable and iterate. Okay, let us see all these four in action now. We will start with take while example. Okay, so what I'm trying to do here is I am creating a list of alphabets by using a factory method, because I need not add any additional element here. I'm just taking a list with finite or fixed number of elements. So this particular list I'm trying to add elements from A to I. 1 2 3 4 5 6 7 8 9, 9 elements I have added, and I'm just creating a stream from that particular list, and I am trying to do a take while operation by passing in the predicate as a input. So basically these two, take while and drop while, will give us a portion or a subset of the stream based on the predicate that we are passing it as an input. Okay, we can say either portion or a subset of the stream by using the predicate that we are passing it as an input. So here if you see, this is the predicate that I am passing it as an input. So using this predicate, it will try to give me subset of the list whatever I have provided here. Okay, let me try to execute this particular example. You will get more understanding. So if you see the output of this, here it is giving A, B, C. So I have added A to I, and in the output I am getting it as A, B, C. So this indicates that we are telling the JVM to drop from this execution when the comparison or the predicate value is true. So this particular take while will take the elements from the source until and unless the condition is satisfied. Once this particular condition is satisfied, sorry, a little confusion over there, until and unless the condition is true. Once the condition is false, this will come out of it. Let us say here I gave a not here. I missed that. Yeah, I gave a not here. The very first element, A not equals to D, it is true. So it will take the value. And the second element, B not equals to D, it is true. It will take the value. And the third element, C not equals to D, it will take the value. And the fourth element, D not equals to D, it is false. So since this condition is false, it will get the subset of the source only till the place where, or till the elements where the condition or the predicate is satisfied. If the predicate is not satisfied, it will not take it. Okay, that's the reason out of all the elements that we have here, we got the output as A, B, and C. We did not get the other elements because the predicate, whatever we have used as an input to the take while operation, is satisfying only for the first three elements. It is not satisfying from the fourth element. That's the reason it stopped taking it. That's the meaning of take while. Take while the predicate condition is satisfied. If the predicate condition is not satisfied, do not take any elements from the source and copy it to the subset. Okay, so that is the meaning of this. Let me execute it again before going to next example. So it is taking only three elements for which the condition is satisfied, and it is giving as a subset. Okay, now let us go to the drop while example. This is simply exact opposite to the take while. So take while will take the elements and it will stop taking the elements till the condition is not satisfied. Once the condition is not satisfied, take while will stop taking the elements. But drop while will start taking the elements from the place where, or from the element where the condition itself is not satisfied. For example, I used the same example. The only difference between these two examples is here I have used a take while for this particular take while example, and for drop while I am using drop while. Apart from these two, all the other code is same. Now let me try to execute this. If you see this output, it is taking the elements from D, E, F, G, H, I. So from the fourth element to the ninth element, it is taking. So this drop while will work exactly the opposite way of take while. So take while will take the elements once the conditions are true, and it will stop taking it whenever the condition failed. Drop while will start taking the elements wherever the condition gets failed, and it will take all the next elements. This is the behavioral difference between take while and drop while. Hope we are clear on this. Now, the other two operations that we have as part of the Streams API improvements are iterate example from Streams method. So streams.iterate. So here I have taken an example that has both Java 8 as well as Java 9 behavior. The first one will be Java 8 and the second one is Java 9. So if you remember, we covered this particular one in our Java 8 playlist. So streams.iterate is a method, and to that particular method we need to provide a limitation because this is a infinite. But whereas in Java 9 they did not make limit as a mandatory one. Instead they have provided another option to provide the condition to the iterator itself, similar to the for loops that we use, the traditional for loops. Here also we can provide the condition directly along with the increment. In case of Java 8 we have only the starting value and the increment, and we need to explicitly provide the limit specifying the number of elements that can take this, that the stream can take it up, because iterate is a infinite one. So to avoid that infinite concept, and not everybody will be able to limit it, and so they have provided an overloaded logic here that a condition can be given along with the declaration itself. No need to explicitly provide the limit here. If you see this particular example, the outputs will be same. See, the outputs are same for both Java 8 and Java 9, but the way the conditions are passed is a little different. Okay, for Java 8 I have explicitly used this limit method on top of iterate method, but whereas I mean here limit is a it's a kind of operator. Okay, intermediate operator. Okay, so this limit is a particular intermediate operator that can be used on top of streams object. Okay, and once the since terminal operator will be at the last, this is a very good example for pipeline of operations in case of streams. So these two are the intermediate operations, and this is a final operation, terminal operation. Okay, whereas in case of Java 9 I did not use any limit method here. Instead what I am trying to do here is I am trying to provide the condition inside the declaration iterate method itself. Since it is an overload object, I am passing it as an argument. Okay, so that's the difference we have, and this is the iterate overloaded method which was introduced as part of Java 9, where we can pass the condition as an argument itself. And this condition in one words we can call it as a predicate as well. So it means that one of the iterate overloaded method will accept the predicate as an input from Java 9. Okay, now the last one we have here is off nullable. Okay, so this particular off nullable till Java 8, this will give us a null pointer exception. We are not supposed to use this in Java 8, but whereas from Java 9 this is still allowed. Okay, now let me show you an example here. So I created two streams here using stream.offNullable. Okay, so what I am trying to do here is I am passing the actual value or proper value in line number 9, but whereas in line number 12 I am passing a null value. This particular line of code, if you use as part of Java 8, it will throw a null pointer exception, but whereas in Java 9 this will not throw a null pointer exception. Let us see this in action by executing the program. So if you see here, the count for a particular stream will give number of elements inside the stream. So here, since I have provided a proper value, so this particular stream has one value inside the stream, and that's the reason I got the count as 1. But in case of this one, the line number 12, stream dot of nullable of null, this will be treated as a empty stream. So the difference between Java 8 and Java 9 is this particular line of code will give null pointer exception in Java 8, but whereas in Java 9 this will be treated as a empty stream without any elements inside the stream. That's the reason stream.count we got output as 0 in case of line number 13, but whereas in case of line number 10 we got the output as one element, because in line number 9 we have added a proper element. So this is the high level with examples that we have covered for the three features that we have here. So what are the three features? Private methods inside an interface and Java collection factory methods and Streams API improvements which were introduced as part of Java 9. That's all for this video, guys. Thank you for watching.